idea on calculus. So that's how the question goes. Okay, let's see the first one. So what they have given is, so I'm going through the examples. Let me explain one by one. How far you are able to understand, please let me know. I will try my best to make you understand.
Okay.
So the first one goes like this. I don't think this maybe that who has undergone the type of questions they might be able to do. Otherwise, a normal student, average student, they cannot deal with this. Highly impossible. I don't know. I don't know the standard what they are maintaining. Here in India, an average student, they will just leave this question and come out. Forget the exam. Forget the exam. That's it. Sure shot. Forget about the exam. What is happening over there? Forget about the exam. If that scribble is given and after that this question is given, that's it. Gone case. Leave it. Leave it. That's it. I tell you, that is for sure. So moment they see this cart, water coming out, so I'll explain this what is happening over here. So this is a cart and you have a jet of water which is coming out at a velocity of v meters second inverse. A jet of water which is coming out with a velocity of v meters second inverse. This is the initial condition. And now the rate at which the water is coming out of this is, they have given mu kg per second. This is what they have given.
Can we like consider a number there if it's
No, they
possible?
didn't consider any number. You don't have to consider.
Oh, okay.
They asked to prove that the change in velocity is 0. This is what they asked you to prove.
Okay.
So that's it. That's all they have given. That means whatever the velocity with which this jet is coming out, with the same velocity, the cart is moving the other side. So that's what they want you to prove. That's what the first question is.
Okay.
No, that's what I'm saying. That's what I'm telling. The connection between the scribbles what you have given and this questions is no connection at all. They didn't discuss anything. They didn't discuss anything literally. So the thing is, the starting point is that, and there is no external force on this, and the surface.
Not even like the gravity, not even weight.
Yeah, doesn't matter, because you see this, the weight is acting this way and your displacement is this way. So weight has no effect. So because they are 90 degrees perpendicular, what done by that is 0. So don't worry about this. And this is connected to something called work energy theorem also. We can do by that. But don't worry about
work
this
energy theorem?
Yeah, there is
Not
something
really
called work
taught in school.
Yeah, I know that. Understood. Understood. That is understood. Don't worry. We'll do.
Okay.
Now the first thing is what, in order to do this, the scribble one, I got the doubt when you have given the first scribble, that set of questions. Initial questions are okay, fine. The next question is like when you are sitting on a boat, you have thrown a towel out. Come on, what is happening like that? When that question came, I got a little bit of doubt about your teacher. Now confirmed. That fellow is too much imagining. Okay, that's simple. This guy, it's like there are some books. I don't know what book he's following, but anyway, that's we'll see. I
think it's GCSE.
What is it?
It's GCSE.
I'm not sure about
GCSE physics something. It's like European board, I guess, for baccalaureate.
I don't know anything about that. I have some reference books like Halde and Resnick.
Okay.
I have another book called there is a 2-part international editions. Maybe he's taking from that, I feel. Okay, but anyway, we'll solve this.
Okay.
Not a big thing. And now the concept wise, this is a tremendous concept. First of all, you have to understand the force. In fact, the net force. The net force is nothing but rate of change of momentum. That's the case. Rate of change of momentum.
Okay.
Now, the net force on this system is 0 because no external force is acting on this. So the rate of change of momentum, so I can write it is delta P by delta T. This factor is 0.
Okay.
Okay, first we'll do this. And now the velocity wise, it is constant. And then you need to know the derivative also. A bit of idea about the derivative. So the derivative part, if you consider there is something called d by dx, without introducing derivative, you cannot handle this. That is a thing.
Oh.
So d by dx of mass into velocity. So the d by dt of the derivative of momentum is d by dt of m into v is nothing
Okay.
but, so there is something called product rule of derivative. D by dt of mv, it's actually m into dv by dt plus v into dm by dt. That means you have the variation of velocity with respect to times into mass plus variation of mass with respect to time into velocity. This is what it is. In fact, you can write like this: m into variation of velocity with respect to time plus variation of mass with respect to time into velocity. So this is what
Okay.
is our force actually, F net. Okay, ma.
Okay.
Now this, they said it is equal to 0.
But what is like the derivative which you considered is about the momentum, like the
Yeah,
d by
derivative
dt?
of the momentum.
Okay.
Derivative of the momentum with respect to time is the force.
Okay.
You need these calculus fundamentals in order to solve this. That is for sure. I thought that you cannot do
Oh.
this. And
I mean, like,
what are the things
mm,
they have given us? They have just written just like that. But as a problem is, it should not be, unfortunately, it should not be thought that way. So what they have given us is the rate at which water is ejected is delta m by delta t. This factor they have given us. That is mu kg per second. You can see the units. This is what it is. Delta m is kg, delta t. So this is the rate
okay.
at which water is coming out.
Okay.
Okay. Now with the
Okay.
velocity v. Okay, we will have slowly I will tell you what we had to do. So delta p by delta t is equal to 0. I can say delta p is equal to 0. First let's put this. Delta p is equal to 0. Delta p is equal to 0 means I can write P final is equal to P initial. Final momentum is equal to initial momentum. I can write that.
Okay.
So what is the initial momentum? Initially, before the start of the cart, it was only water which is coming out. Okay.
Okay. Okay.
Right. Right. Now, what we do is that we take the derivative on either side. So that is delta PF, that is a variation of momentum, final momentum divided by time is equal to variation in the initial momentum divided by time. So something like this, you can consider it like a derivative. Why I will tell you, you will understand slowly. So, okay, ma. Now this is
Yeah.
what it
Okay.
is. Now let's work out this one. What is the final momentum? Forget about delta T. What is the final momentum? Water, let us say the mass m of water is coming out, and let's try, before that let's write the initial thing. Initially it was only water which is coming out, right? So the
Yeah.
mass of water into velocity of water, right, divided by
Okay.
delta t.
Delta t.
Delta t,
Okay.
this is there. And now this delta m by delta t is nothing but they have given it as mu. So it is mu times v.
Okay.
That is the first part. Now there is
Mm.
another thing is also there. Now the water is ejected on the right side. Okay.
Okay.
Now that is going in the positive direction of x-axis. I consider this momentum as positive. And
Okay.
because of this, there is an action and reaction force. Because this is, if you consider this is action, the reaction acts on this cart. And the cart moves on the left side.
Okay. Oh, so it
Yeah.
because of the force of the water
Force
moving
of the
out.
water, the cart
Yeah.
is moving the other way. It's that's what
Okay.
happens,
Okay.
say, even in a car. The
Is it like a airbag thingy when the airbag comes out and it acts on the passenger?
yeah, yeah, airbag. You need not consider on to the condition of an airbag. You can simply consider
Oh.
a situation like you just take a balloon, blow air in it,
Okay.
and just release the balloon.
Ah. Okay.
That
Okay. Okay.
situation you consider. You are going to the
Okay.
most, like your teacher made you so complex. So your thoughts become so complex.
He
In
taught us
reality,
about like airbag in like on
need
Monday.
not. This is a very simple thing you can think. Just blow the balloon.
Okay.
That's what the Indian and that's the Indian mode of
I think
thinking
that's
thing.
why Aditi stopped schooling, I guess.
Maybe. I don't know.
Yeah.
I don't know. I don't know. So it's like the Indian mode of thinking is entirely different. There was an joke is there, I think. It's like uh, there was, they want to check, there is an Indian company, they want to check whether it's a soap factory. They want to check whether soap is there or not. It is filled inside the cover or not. I hope you know this.
No, I don't.
You don't know. Okay, I'll tell you.
No. Okay, okay.
The Europeans, this everyone, they asked them to invent a way how to check whether the soap is filled in its own box, in its small
Okay.
paper cardboard box. Okay.
Okay.
For that, the first person suggested I will use ultrasonic waves. Second person suggested I will put an X-ray machine. Each one will cost like lakhs of rupees. They called an Indian and they asked you what you suggest. When it is moving on the conveyor belt, I will put a fan. So because of
Oh, yeah.
oh, the,
Okay, okay.
the paper will fly off.
Oh, okay.
So this investment is 300 rupees.
Oh, yeah.
So it's like 1,000 rupees max, right? So I'll put a
Okay.
fan on. So this is how
So
the
like,
Indian brains will think.
and like, is the like physics in India easier than this? Like,
Yeah,
a lot easier.
definitely. This is like a complex. Actually, you will learn the concept, but it's like a little bit complex. The ideas are a
Okay.
little bit complex, but you should be taught. The thing is that you should be taught the derivative concepts pre-year. There's a map course you have to do pre-year while doing this level problems. Actually,
Oh, okay.
no, otherwise it's not possible. Next, trigonometry will
Okay.
come. That is the issue. You have to resolve the components. Trigonometry, those things will come. So let's see. This is the initial momentum. That is, you understood. The rate of change of initial momentum is equal to rate
Yeah.
of change in the final momentum. What is the final momentum? Final momentum constitutes two things. Final momentum is the mass of the cart and the velocity with which the cart is moving. Right?
Okay.
The velocity
Okay.
with which the cart is moving. So we assume that the mass of the cart is m and the velocity with which it is moving. So m, v will put a delta. So here we'll put that. And now plus, it's the same stuff, but this is in the negative direction with respect to the flow of water.
Yeah. Okay.
So we will write here the same delta m into v, that is for the water case, whole divided by this whole divided by delta t will write. This is equal to mu v. Okay, ma.
Okay.
Now the mu refers to the rate at which the water is ejected. So mu is represented as delta m by delta t. So that is here also it is coming. Now you have minus of delta mv divided by delta t is equal to, you can write plus, okay, this is negative, plus Here, let us separate it as fraction. So it is delta m into v divided by delta t. That is equal to mu times v. But the delta m by delta t is again mu, right? This part
Okay.
is mu. So this will replace mu v. The mu v gets cancelled. So
Okay.
you are ending up with an equation delta mv divided by delta t with negative sign, that is equal to 0. But the mass of the cart will remain the same. There is nothing like the loss of mass in the cart. It's the water and the cart system they are treating separate. Okay. They assume that there is
Okay.
no change in the mass of the cart, and then the water which is ejected is very negligible. So I consider the mass of the cart to be remaining constant. So m into
Mhm.
delta v by delta t, that is equal to 0. So from this equation, we can write delta v is equal to 0. The change in velocity of the cart is 0.
Okay.
So which means that the cart, whatever is moving, it is moving with respect to the same velocity. That's way we can think of. That's what the equation it says. So there's a first thing. So it says that we can also get the same answer is conserved, and then can be no change in the velocity. That's all it says. So the cart moves with the same velocity as that of this one. The first thing. And two-dimensional collisions they went. That is even this is one of the toughest thing, Amma. Two-dimensional
Oh,
collisions. Okay. So I'll tell you one of the some simple thing I'll tell you. Later we'll go to the complex thing. So prior
okay.
to that, you have to understand this. And now let us say a ball of mass m is hitting a wall straight, perpendicular. First of all, you have to
Okay.
understand this. Then only you can handle.
Yeah.
Is hitting the wall with a velocity of v.
Okay.
With a velocity of v, right? It is hitting the wall
Okay.
like this and bounces back with the same velocity v, and bounces
Like
back with the same
at the perpendicular.
yeah, perpendicular. It
Okay.
bounces back with the same velocity v. And now you have to understand what is the rate of change of momentum. What is the change in momentum? We have to calculate. It's a very simple
Okay.
scenario. And now when I write the initial momentum, it is moving in the negative direction, right? Negative x-axis. So the
Okay.
initial momentum, we'll write it as minus mv.
Yeah,
Okay.
okay.
And now
Okay.
once it hits the wall and it bounces back, we will write the final momentum as, since this is now it is positive direction, so it is mv, right? It bounces
Yeah.
back in the same velocity. So we'll write mv. And now if I ask you what is the change in the momentum, that is P final minus P initial.
Yes.
So it happens to be MV minus of minus MV. So
Okay.
MV plus MV becomes 2MV. So you got MV plus MV, which is 2MV.
Okay.
This is the part one. That's one thing.
Okay.
Now there is another thing. So this is also a kind of a collision. You can say this is a collision.
Okay.
Here that hits and reflects back with the same velocity. Now, always if it is a wall case, remember this, always consider the momentum perpendicular to the wall.
Okay.
If a ball is hitting the wall, always consider the momentum perpendicular to the wall. So this
Okay.
is one thing you have to know. The further thing I told you, resolving components, is this one. There's a second thing what you have to know. If this is theta, and let us say this is the momentum vector, if this is theta with the horizontal, this is happens
Yeah.
to be px, which is p cos theta, and your py, that is nothing but p sin theta.
Okay.
Okay, ma.
Yeah.
Now
Okay.
that's how we resolve this thing into components. First, you had to understand this. I hope
Okay.
you know what is sine theta and cos theta. Presuming
Yeah.
that we have to go further. Okay, that is very important. Now, solving
Yeah.
physics without trigonometry is not. It's impossible, more or less. Impossible, I tell
Yeah.
you. And now the
And
scenario. What
anyways, we
this?
have like calculators to solve everything. So that's no, like we have everything. You know the TX Inspire calculators
Yeah. I
where
mean
we
that.
have.
Yeah, you have sin x, cos x, everything. But
In that
what
zone.
to put where, that is most important.
Oh yeah, that yeah.
Calculator will be there. But the thing is, how do you apply the concept is most important. You have
Yes.
sin x, cos x, and you will know the angles. That's that much only you know. And
Yeah.
what to put where is the most important thing. Later, that's the most important stuff. So let's see this scenario. So these are the things they should teach this actually, and later they can do whatever two-dimensional collision, one-dimensional collision, whatever they want to do, they can let them do. First, they have to teach this. And now let us assume that there is a ball like this of mass m,
Okay.
and it is going with a velocity of v. Okay, ma, with the momentum,
Yeah.
the
Okay.
initial momentum is like this. Initial
Okay.
momentum
Okay.
is mv. So it is going in the positive direction. So I write this as mv. And now it hits the wall at an angle theta with respect to the horizontal.
Okay.
It hits the wall at an angle theta with respect to the horizontal. And then this is my initial momentum. And then it bounces back like this at the same angle theta. Okay, it bounces back at the same angle theta.
Okay.
Now the final momentum, it is bouncing back with a negative direction, right? So we'll write minus mv. It bounces back with the same velocity and the mass is also same.
Yeah.
This is a condition what we have taken. And now I told you, you got to resolve this into the components. And now for resolving it into components, what you have to do is you have to draw a parallel lines like this. And now this one becomes the py for the initial momentum, and this one becomes
Okay.
px for the initial momentum.
Okay.
And now the px will be of this direction, because this is this direction, so this will be of this direction.
Yeah.
And now the initial momentum will have the y direction this way, because it is pressing down only, no? So it will
Okay.
have the y direction this way. Okay, ma'am.
Yeah.
So y direction this way. Okay, it is pressing down. So you can, and now once it bounces back, it will have the final momentum this way, upwards. This is the y
Okay.
components. So when you see the
Okay.
y components, this y component, this is also this way. So you see the result, how the result, to see the resultants. Okay, I have to see the resultant. This is the x. So this one, and now it will be like this. Yeah, this is how the initial momentum y direction will be. Okay, this is my
Okay.
x direction.
Yeah.
Your resultant vector is this way, means the y vector is also this way only.
Okay.
So this is how you have the initial momentum. And now this py, you know, just now we solved, this one will be mv sine theta.
Yes.
Mv sine theta downwards, and now mv cos theta this way on the x-axis, x direction you have, that's mv cos theta.
Okay.
Now you have this. And now when it is bouncing back this way, you have the x component of momentum, negative mv cos theta you will get now. Because it is, the momentum is, it bounced back in the opposite direction, no?
Yeah.
So
Yeah.
it is minus x direction. So you get minus mv cos theta, and the mv
Yeah.
sin theta part is on the top. But because it is negative y direction, you have minus mv sin theta this way, opposite. Okay, ma.
Okay.
Now
Yeah.
you see these two are equal and opposite, they cancel each other actually.
Okay.
They cancel each other. And now you have this thing is the final initial and final momentum, but the thing is, this is a, okay, this is not satisfying thing. I didn't tell you the satisfactory. This wall is not unmoved. This is one way of seeing that. Because of change the momentum, the momentum is imparted to the wall actually. The y components will cancel out. Y components will cancel out. Only the x component will sustain. So that is called the perpendicular component. This is what I want you to see. The perpendicular components will sustain. And now the perpendicular components will contribute the change in the momentum. Okay, ma?
Okay.
So
Yeah.
you have the thing is like the final is minus mv cos theta, and initial is also minus mv, initial, final minus initial, no? That is also
Yeah,
minus
yeah.
mv cos theta. So you will
Okay.
get minus 2 mv cos theta will be the change in the momentum in this case when the ball hits the wall like this. So what necessarily you have to do is you have to resolve the things into components.
The cos theta can't get cancelled?
No, cos theta will not get cancelled.
Oh no, it's in multiplication.
No, cos
That's
theta will
why,
not
right?
get. It's multiplication. It's like x cos theta. If you add x cos theta plus x cos theta, what you get is 2x cos theta.
Oh, okay, okay.
So instead of
Okay.
x, you have mv, 2x cos theta. Instead of x, you have mv. So this is how you get minus mv, minus 2 mv cos theta. That is perpendicular to the wall only you have to consider. Whatever the momentum you get parallel to the wall, the momentum is not imparted to the wall. So it goes to 0. So this is the most important thing what you had to consider. This should be taught. After that, we'll consider two balls collision. There's a single ball collision with one stationary object. There's a thing is like one is moving, the other is stationary. Other is unmoved. It will not take any momentum at all. So this case should be solved first prior to that. And then they have to go to this one. You are undergoing a very tough course. I understood. Very much I understood. Okay, clear. Can I clear? Yeah, I hope you understood this part.
Yes, yeah.
Next part is like this. So let us say you have a ball like this with an initial velocity of u, m1, u1, and there is another ball with the momentum m to u2, initial momentum m to u2. This is having initial momentum m1, u1. They collide at certain angle. This is angular collision means how do I define the angular collision? This is how it is moving. This is coming from somewhere like this.
Okay.
And it's colliding like this. And this is how we treat the angle theta.
Oh, okay.
That's how you have to take. Otherwise, the other way of looking at it is very complex, very complex. M to U2, and again it's going like this, and again there is another ball which is coming like this and hitting this. This is M1, U1. This is what the angle they are considering. This is called angular collisions.
Okay.
It has collided at an angle. And for this, what you have to do is resolve whatever the angle they have given, resolve the momentum into components. That is the momentum you have to resolve into components, and conservation of momentum you have to apply in x and y directions. That is a collision in 2 dimensions. So x dimension, you apply the initial momentum in the x is equal to final momentum in x. Similarly, initial momentum in y is equal to final momentum in y.
Okay.
So this is how you have to apply and see. So for that, you have to resolve the things into components, and little bit of trigonometry is involved in this. Okay, ma.
I understand it. Yeah.
So this is what the situation what they're talking about. Very complex situation. It's not. I never thought that they are going to ask you that this much complex questions for you. Never. Seeing that scribbles, oh, this is simple. This is simple. This is simple, simple. Like that, I went. This is too much. Way too much. Way too much for you. Way too much for you. So first, if you solve the so, but the thing is like how do you resolve this into components? So the thing is that let us say the first object.
Like
So
when
what
we
do they do?
asked him like how will we so how like
Yeah,
some
I
of
will
the
tell you. I
students
will tell you.
were
I'll tell you.
like some of the students were really weak in physics, like in our class. They
Okay.
asked him like how can we solve like such hard questions, and he was like, your imagination power should be really strong for it.
Not just imagination, Amma. You need the math also very good. You should be really good at mathematics. Then
Yeah.
this course you can handle only if you are really, really good at mathematics. Then only you can handle
Mm,
this. So let's
not really.
no, no, this is not a joke. This is a huge task.
Yeah.
So let's see this. So this is like this. So suppose the thing is like this. Suppose you have a momentum vector like this. Let us say m1 u1 first of all. So
Okay.
it's like this. So it's having an angle theta. And you can have the m2 u2 which is making a different angle with respect to x-axis. So it can be any direction. So let us say this is m2 u2. I'll tell you what you have to do. Now you can resolve this into components.
M2U2 means it's
Yeah,
another
momentum, another particle. Let us say the
Okay.
second particle B that is having momentum
Okay.
m2 u2. The first particle A, it's having momentum m1 u1.
Okay.
Now when they collide like this, what you have to do is that so initially let us say that they are having a different angles with respect to horizontal and they are colliding.
Okay.
So that's how at the time of collision also they can give like at this point they have collided like this. They can give any kind of scenario, doesn't matter. Depending upon the angle what they have given, based on that we can go. So like this, different scenarios can come up. So initially what you have to do is that you resolve this into components. If this is moving m1 u1, this you can write it as m1 u1 cos theta, that is x component, and the y component is m1 u1 sin theta, that is a y component. Okay, ma?
Okay. Okay.
This is the y component, this is the x component. And now for this, let us say the angle is phi. This is having the component, let us say m2 u2 cos theta, and the y component is with respect to the angle. If it is given with the horizontal, then this is m2 u2 sin theta, sin phi. Okay, we have given a different angle, sin phi.
Okay.
Now what you have to do, the x component of the momentum you have to equate. That means m1 u1 cos theta plus, assume that both angles are same, then you little bit the problem gets simpler. m2 u2 cos theta, we assume both angles are same. Now that should
Okay.
be equal to the final momentum. Final momentum, the angle will change definitely. So we will get m1 v1 cos phi plus m2 v2 cos phi. So this is how it will turn up. So the initial momentum in the x is equal to initial momentum in x, final momentum in x. Initial momentum in x is equal to initial momentum in x is equal to final momentum in x.
Oh, okay.
Initial momentum in x direction is equal to final momentum in the x direction.
Okay. So initial momentum of a ball, like of
Yeah,
mass
ball.
A.
Yeah. And both the things you have to consider. This is for
Yeah.
the
Okay.
ball. When I say initial momentum, it is the momentum of A plus the momentum of B.
Okay.
So initial momentum of A in the x direction plus initial momentum of B in the x direction is equal to final momentum of A in the x direction plus final momentum of B in the x direction.
Okay.
So that's
Okay.
how we
Okay.
consider. That's how we write. So it can be different angles or it can be anything. You can do this. No issues. Now
Okay.
the other part is the y components we had to equate. M1 U1 sine theta plus M2 U2 sine theta, assuming the both angles are same, M1 U1 sine theta plus M2 U2 sine theta is equal to the final momentum in the y direction, that is M1 U1 sine phi, M1 V1. This time the velocity has changed. M1 V1 sine phi plus M2 V2 sine phi. So this is how it will be. Not easy. Not at all easy. And then whatever the angles they give you, based on that angles, you have to substitute. The masses will not
Okay.
change. And now,
Yeah.
so they will give simply the. Are you introduced to vectors by any chance?
Yeah. We do
Oh my
use
god.
vectors.
Okay, fine.
But he like never specified. Like we asked him today only.
Huh.
Like when do you put the vector arrows and when do you don't?
Oh my goodness. Oh my
But he
goodness.
was like, he didn't say anything. Just ignored us.
God. My goodness. Okay, I tell you, I had to. Okay. So let us say it's like two things, Amma. U1,
Okay.
I should say U1 sine theta is like it's like very tough. So it will be given like this. U1 bar happens to be U1 cos theta I cap plus U1 sine theta j cap. It's actually this. So whatever the vector they give you, no, U1 cos theta happens to be the I component and U1 sin theta
Okay.
happens to be j component.
What is the
Take it
cap
grand.
thing?
The cap thing. Okay. Oh, you are not introduced to vectors, that means. Okay. The cap thing I'll
Oh,
tell
we
you.
give like the arrows.
Yeah,
Like
the cap thing is that I'll tell you. There is a
okay.
meaning for the cap. It's like the I cap refers to the x axis. On the x axis, I moved 1 unit.
Okay.
I moved 1 unit in the positive direction of x axis. That's what it says.
Okay.
And the j cap refers to I moved 1 unit in the positive direction of y axis.
Okay.
So that's what the j cap means. So this is how they give the vector u1 bar that refers to the first object. The u2 bar also they will give you, that becomes u2 cos theta I cap plus u2 sine theta j cap.
Okay.
Sometimes you got to find this vector if the angles are given to you.
Okay.
Okay, that is also another tough task. Okay, now
Like
this is clear.
how do we when we find like we need the magnitude as well as the direction, right? To find the
Yes.
vectors.
They'll give you this u1. What do they
Okay.
give? What do they do is mod u1 they will give you. Let us say there's 3 units, and they will simply tell with respect to the horizontal this object is moving at an angle of 30 degrees. Let us say.
Okay.
Then you got to generate the vector. This is 3 times cosine 30 plus 3 times sine 30. 3 times cosine 30 is root 3 by 2 and 3 times sine 30 is half. So that's how you get the vector 1.
Okay.
The vector 2 is the same way you have to generate.
All right.
It's
Okay.
literally a tedious task. It needs a lot of time. Maybe we can sit sometime on the next class, because you have just sent me the questions, right?
Yeah.
I'll make the answers, and then this is a fundamental idea. Fundamental idea wise, you can do like this. This is what I
Okay.
see. These are fundamental ideas. With this, you can give a try tomorrow exam. Don't worry too much about that. But the solving those problems, no, that's a really big
Yeah.
task. So that solving problems, that part I will prepare the answers
Okay.
and we'll discuss in the next class. The
Also,
answers part.
like tomorrow I have exam at France time 4 o'clock.
Okay, ma.
So
Okay.
like Can you like take class tomorrow maybe?
Yeah.
Of
What time, Amma?
at you uh maybe maybe 2:30, like just as on
2:30. 2:30 means what time it will be here? 2:30. That's 4.5 hours. I have to add
7
7 o'clock.
is 7, yeah,
7:30 may be possible, Amma, because
7:30.
7:30 possible. 7:30,
Oh,
yes,
7.
7:30 is possible.
Oh, it will be like 3. I
Yeah,
have
it
to
will
go
be
to
like this.
school then.
Yeah, yeah, yeah,
Yeah.
yeah, yeah. It's really tough. Very tough. Very tough for you. Or
So like,
I
okay,
will be tomorrow. I'm having a first shift, so I'll be arriving at 3 o'clock Indian time.
3 o'clock.
3 o'clock Indian time. Maybe we can give a try. If I come at, if we start at 3:30 afternoon, is that okay for you? 3:30 Indian time. Afternoon will be like
No, I'll be in school
12
maybe
o'clock.
because
12 o'clock
oh,
France time.
12 o'clock.
12 o'clock France time, or even 11 o'clock France time.
No, I'll be in school till 12.
Till 12 you are there in school.
Yeah, yeah,
12:30.
yeah.
What time you will come back, ma?
I will come back up for lunch like at maybe 1:30.
1:30 you will come back, and again you have to go back.
Yeah.
Oh,
Yeah, at 3:15 something like that.
you had to go back to school. 1:30 you will come back.
Yeah. Yeah, yeah, yeah.
1:30 means it is like 4.5 hours if I give. So it will be 6 o'clock.
Yeah, yeah, yeah.
6 o'clock is too tight. Too tight. It's
Oh,
tough. Oh, don't worry. Don't worry. You uh, try to answer with this funda first.
okay, okay.
You give it. You give a try. The answers I will prepare anyway. You have to write some final exam or something. That is very useful,
Okay.
right? Or it will be
Yeah.
like this in between. One exam will come and it will go.
Mm, like what? I didn't understand.
No, it's like I don't know the methodology of the examination. Is it like a year-end exam? Do you have?
No, no, no. It's just like a big class exam,
Okay,
not like a final exam. We final exams are in June ending.
June. Okay, okay. Now this is
Yeah.
like a slip test. What he's asking.
Yeah, 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 yeah.
Okay, okay. In order to make you okay, that means the syllabus will come once again for you. Definitely, you will see this.
Yeah.
You are right for the exam. Okay, you have, but anything is given like this, you please send me before, Amma, because these things are really, really tough.
Oh,
So
he just
I need.
gave us yesterday only.
Oh, okay, okay.
Yeah.
Then,
So
then, then once you receive anything like this, you just take a photo and then immediately you send
okay,
whatever.
okay.
So I
Yeah, yeah,
will.
sure.
What I do is this tomorrow. I will have early morning. I'll have some time. So during that time, what I do is I will prepare this questions and answers for this
Okay.
particular set of questions. If you
Yeah.
don't mind, can you send whatever you have sent not to my phone, to my email?
To your email, like
Email.
the images.
Yes, yes. Images to my
Ah,
email.
okay,
That
okay.
is
I will do
better.
it.
Because
Yeah,
it's
okay.
easy for me to share
Ah,
here on
okay,
the
okay.
screen,
All
and
right.
then we can do that. Please share it in my
Okay.
email. I have already given you my email ID. It's already
Okay.
shared. So you
Yeah,
please
yeah, yeah.
send it to my email. Then we can share across and then see. Because the
Okay.
mobile you have sent me, the mobile is taken by my son.
Oh,
Okay.
okay.
So, but anyway, this is the funda concept wise. This is the one, Amma. This is what you have to understand. So
Okay. Also, can you like discuss just one question how it is given in Indian curriculum in physics?
physics, that is more easy than this. What it is, that I'll tell you.
Okay.
What is given is like this.
Yeah.
There is a ball like this. A ball of mass m is equal to 3 kg,
Okay.
and the velocity is like 2 meters second inverse.
Okay.
Okay, it is hitting a wall
Okay.
like this at an angle of 60 degrees.
Okay.
This all is given. What's that? And it has bounced back with the same velocity
Okay.
and with the same angle of 60 degrees. That's all is given. And now what is change in momentum? You will simply apply 2mv cos theta.
Okay. Oh
Finished.
my God. This is
That's it.
so easy.
That's all. That's all is given. Maximum. So
Like they give
without teaching,
everything, just like they give velocity,
this
they give
should be,
mass.
yeah. This is the initial lollipop to be given first to understand what it is. Without that, how do you handle? How do you expect to handle? There, you are not born from air. I don't know. Suddenly something pops up, and it was a big joke. There was a big joke. Like I tell you, this professor is started telling something on the board. Entire full board, he filled everything with the equations. Finally, one student rose up, sir. Which subject you taught? That was his question. First doubt. It is like that. I think your people are doing there. Which subject you taught? That was the condition. It's not that what he knows, Amma. Actually, he has to impart what he knows to you. I think they are failing there.
Yeah.
I think they are failing there. No problem. We'll do that. The first thing you understand this is clear, but this 2mv
Yeah.
cos 60 is in the negative direction. That's all you have to understand.
Yeah.
2mv cos 60 is in the negative direction. That's it. This is wall is static. Wall is static and the ball is only the one which is moving.
Okay.
Now got it. Now the situation what they have given you is, this is not a wall now. Instead of this wall, there is a ball. That's it. Instead of the wall, they have given a ball.
Okay.
Now, that now first one static, one it is moving, then it is easy for you to understand. First of all, the same thing you will apply to the next thing. That's it. See, for the ball, because the momentum, the impartation of momentum has not changed anything for the wall, right?
Yes.
So that part is zero. But in the case of the ball, the momentum is imparted to the ball also because of this.
Okay.
So the other part will come into the picture. That's where it comes into the picture. So that's how you get the equation. The vector equations will come. The x momentum you have to equate with the x momentum, and the y momentum you have to equate with y momentum. And the second thing is, no, you need a lot of practice in order to first resolve into the vectors. If they have given the vectors, then that is easy. What you have to remember is, you just remember this one, Amma. U1 bar, they will give it as ux I cap plus uy j cap, right? And this is u2 bar is u this is u1x, I'll write u1y. Similarly, u2 bar is u2x I cap plus u2y j cap. So these two they will give you. This vectors minimum, the mass of each body, that is ma and mb. This thing they will give you. And one of the vector, let us say the velocity vector, final velocity of the first body. So it is like v1x I cap plus v1y j cap. This they will give you. They'll ask you to find what is v2 bar.
Okay.
This is how the question will come. What you have to do? You have to do ma into ux1, okay, right?
Yeah.
And mb into ux2 is equal to, don't take it like a square, it is 1 and 2, okay? Now that is equal to ma, it has gone to the velocity vx1, okay, plus mb into vx in the second case. Now this vx2 you can find it because you know these are all the things you know. right?
Okay.
Now
Yeah.
you will find this one, Vx you will find. Clear? And now
Yeah.
similar
Okay.
equation you apply for the y. So what you
Okay.
will do, MA into that uy in the first case and MB into uy in the second case is equal to similarly MA into Vy in the first case plus MB into Vy in the second case. So Vy in the second case you can find, you know all these things. You know all these things. Now you will find the
Okay.
Vy and Vx. Clear, Amma? So
Okay.
depending upon the situation, we'll work out. This is easy. After that, if you know how to solve for Vx and Vy, rest of the things are easy.
Okay.
So this is how you can apply. This is what I have seen with a little bit of time. Later we'll work out by maybe next class we'll plan. So
Yeah.
depending upon
Okay.
your availability. So
Yeah.
you can inform me because I am available tomorrow right from 3:15. Okay, ma, Indian time.
Okay. Yeah.
That is
Okay. Okay.
about you can say 11 o'clock France time onwards. I am available.
Okay.
So you can give a message. So by the time we can interact once again and then have a look at it. Okay,
Yeah.
ma?
Sure. Okay. Okay. Okay.
Okay, ma. Take care. We'll
Okay.
close today.
Okay. You too.
Sufficient.
Yeah. Yeah. Okay.
Okay, ma.
Okay.
Take care. Bye.
Okay. Bye.